You chose your platform. You understand the agent loop. But there is something you do not know yet. The thing that separates agents that work reliably in production from agents that fail unpredictably. How an agent actually thinks, not as a metaphor, at the implementation level that determines whether your agent succeeds or fails. In the next 30 minutes, we open the agent up and look inside. Memory systems, system prompt engineering, tool design, React reasoning, planner patterns. This is episode 3, How Agents Think. Welcome back to WealthWise AI, Smart Money, Smarter Future. In episode 2, we moved from theory to terrain. We mapped 7 platforms: N8N, Mate.com, LangChain, LangGraph, Crew AI, AutoGen, Relevance AI, and the Claude Plus MCP stack. We covered N8N architecture in full: trigger, processing layer, AI agent node with 400 plus tools and action outputs. 9 we introduced MCP, the protocol that standardizes how AI models connect to external tools. We gave you a 4-question framework: technical level, data privacy, scope, and time horizon. The answers point to your platform. If you have not watched episode 2, the link is in the description. The series compounds: 2 agents, same platform, same task, radically different results. The difference is never the platform. The difference is what you put inside it. Memory design, system prompt, tools, reasoning pattern. Today we cover 6 implementation pillars that separate a toy agent from a production one. Every AI agent has a working memory called the context window, the finite buffer of text the language model can see at any moment. Think of it as a whiteboard. The agent can write, read, and reason about everything on it, but the whiteboard has a fixed size. When it fills up, old content falls off the edge. The agent forgets it. Context windows have grown dramatically. Claude reaches 200k tokens, Gemini 1 million, but size is deceptive. A large context window delays the problem, not eliminates it. When the window fills, the agent silently loses earlier context. The LLM returns an error, or inference cost spikes because you are paying per token on every request. The solution is intentional context management. Summarize tool outputs rather than dumping raw responses. Use structured formats that convey maximum information in minimum tokens. Prune irrelevant history proactively, and design your system prompt to be as token efficient as possible. Historical facts and knowledge bases belong in long-term memory. Vector databases. A vector database is the long-term memory of a production AI agent. Traditional databases store exact matches. Search for refund policy, and you either find that phrase or find nothing. But the user asks, how do I get my money back? Relevant document is titled Returns and Refund Procedures. Different words, same meaning. A vector database stores information as mathematical vectors, numerical representations of meaning. Similar meaning means similar vectors. When the agent queries, it finds the closest vectors and retrieves those documents. This is RAG, Retrieval Augmented Generation. The full knowledge base never sits in the context window. Only the most relevant chunks do. Top vector databases in 2026. Pinecone for managed cloud, Weaviate and Qdrant for open source self-hosted, PG Vector for teams on Postgres. In N8N there is a native vector store node. Connect Pinecone or Weaviate, configure your embedding model, and the AI agent node automatically retrieves relevant context before reasoning. No custom code required. The system prompt is the agent's constitution. A mediocre one. You are a helpful AI assistant that produces a polite, generic responder with no understanding of its role. A production-grade system prompt has 6 components: role, context, constraints, output format, tools, and success criteria. What a good outcome looks like so the agent can self-evaluate. 5 rules for system prompt engineering. Write positively. Tell the agent what to do, not just what not to. Be specific about audience. Front-load critical instructions. Test with adversarial inputs to verify guardrails hold. Version control your prompts like code. And treat every token as premium real estate. Verbosity is a cost you pay on every single invocation. An agent is only as reliable as its tools. 5 principles for AI reliable tools. First, precise, unambiguous description. The agent decides which tool to call based entirely on your description. If it is vague, the agent guesses. Guessing produces errors. Write it as 2 sentences to a colleague who has never seen the tool before. Second, strongly typed parameters with examples for non-obvious formats. Third, deterministic structured output with a clear success or failure signal every time. Fourth, atomic scope, 1 tool, 1 job. Fifth, idempotency where it matters. If the agent retries after a network error, the tool should produce the same result whether it runs once or 3 times. REACT stands for reasoning and acting. Before REACT, models produced answers directly, no mechanism to verify reasoning against the real world. REACT makes reasoning explicit. Thought, internal reasoning about what is known and what is needed. Action, the tool call. Observation, the tool's actual output. Then another thought, informed by reality. Cycle repeats. By externalizing thinking as text, the model catches its own errors. If the observation contradicts the thought, the next thought corrects course. This is chain-of-thought reasoning applied to agentic workflows. In N8N, set the agent type to React Agent. In LangGraph, you design the state machine explicitly. Either way, explicit reasoning, real-world grounding, iterative refinement. As workflows grow complex, a single agent degrades on both planning and execution. The planner-executor pattern separates these. The planner receives the goal and produces a structured task list: objective, required tool, success criteria, fallback action. The executor receives 1 task at a time, executes with precision, returns a structured result. The planner reviews and moves forward or revises. The complete architecture: trigger fires, context assembly runs, system prompt, conversation history, RAG retrieval. Planner produces a task list. Executor works through each task using AI-reliable tools. Results feed back to planner. Every action logs to an audit trail. Input, reasoning, tool called, parameters, output, final action. That audit trail is not optional in any production system. In episode 4, we enter part 2 of the series, Financial Industries. We build the financial trading agent, automated signal detection, trade execution through broker APIs, portfolio monitoring, risk management with stop-loss automation, and market research agents scanning news and filings, Forex, indices, tech stocks, crypto. Tuesday, 7 in the morning. Do not miss it. Before we close, 30 seconds. Hit the subscribe button right now, not later. The people who subscribe today get episode 4 automatically. The people who mean to subscribe later, miss it. Hit the like button, 1 second, real reach impact. Turn on the notification bell. Episode 4 is the one the trading community has been waiting for. Drop 1 comment. Your industry, your problem, your country. #WealthWise request. The most requested use cases become future episodes. You leave this episode with what most developers do not have when they start building: context windows, vector databases, system prompts, tool design, React, planner executor, a complete production architecture. That is your edge. Smart money, smarter future.